Let me show you how to solve vertical acceleration problems. The basic idea, the fundamental idea here is that we're going to be using Newton's second law, which is F equals ma, right? But F is not just one of the forces. Like, for example, it's not just that force, but it's the sum of all the forces. We got to figure out all the forces acting on this mass and set the sum of the forces equal to m times a, right? So here we've got a 5 kilogram mass, right? We've got a string with a tension of 65 newtons, so that's definitely one of the forces acting on it, right? There's 65 newtons, and that's in the positive direction. But we presume that this thing's on Earth and that there's also the force of gravity, so there's going to be a downward force on this thing, right? And the force of gravity weight is always mg, right? So this force is going to be 5 kilograms times 9.81, right? And that's 49.05 newtons down. I'm going to make that a negative force. This guy's positive, right? Now we're ready to use Newton's second law. We've got all the forces acting on it, right? So we go 65 newtons up, 49.05 newtons down. Whoops, got to do the little angle thing like that, right? And then that equals 5 times, and we don't know the acceleration, right? Okay, and then we can do a little math here. 65 minus 49.05 is 15.95. So because this upward force is bigger than the downward force, this is definitely going to be an upward acceleration, right? So 5 times a, right? And then I'm going to divide by 5, and I get 3.19. Now we only have 2 sig figs here, so I guess we'd have to say 3.2 meters per second squared upwards. And it's always, positive to us meant upward, right? So when we do these things, you always have to decide which way is positive. I'm always going to make up positive, down negative, right? But not everybody is going to use that same convention, so we need to use words that they'll understand. Okay. I love this thing. So anyway, that's the first example. That's calculating the acceleration. The other thing that, of course, we could have you do is to figure out the tension given a certain acceleration. So let's do one of those. Right, so here's this elevator. It's accelerating downward, which means, by the way, the tension upward will be less than the weight. And then we want to know what the tension is in the cable. So that's our unknown, right, is this tension, right? It's accelerating downward, so we know this force is actually going to be a bit more, right? So that force is 510 times 9.81. 510 times 9.81 is 5,003.1. Right? That's going to be downward. This is an unknown force, so you always make those positive, right? And now we're set. We're going to use F equals ma, right? That all the forces are unknown force, which is the tension. Tension's just a force in a cable. If it's attached to the top of the elevator, then it's an upward force, right? Here we know it's going to be an upward force because it's not accelerating downward as fast as it would if it was in free fall, right? So it's got to be an upward force, right? The weight is definitely a downward force. So we go minus 5,003.1, right? And then that equals 510. Now, because it's a downward acceleration, right, that makes this acceleration a negative acceleration. So that's what we do. If it's downward, make it negative. If it's accelerating upward, make it positive. Okay? Ta-da. Okay. And then 510 times 1.5 negative is negative 765. Right, so you got T minus 5,003. Right? Okay, and then I'm going to add this 5,003.1. I'm going to add that to both sides, right? So and so I get that the tension is upward 4,238. right? And then we have only 2 sig figs, so I guess we'd have to say it's about 4,200 newtons. Now, since we're talking about the tension in a cable, it's presumably attached to the top of the elevator, right? We don't need to say necessarily that it's upward because that's the way it would be. I'm just going to write up here because I have to satisfy my obsessive compulsive disorder here. Yeah. Okay. So that's the second thing you could do, right? Is solve for what the tension is, right? And then the final thing is that you could you could have a cute little Suvat problem, right? We got 5.3 meters per second. It's moving downward, right? It stops in 2.10 seconds. Okay. And all this means when there's a Suvat thing is that we're going to solve the Suvat problem, get what the acceleration is. Then we're going to plug it into our little formula, right? So presumably this guy there's some tension upward, right? Now notice that it's moving downward and it stops moving downward, right? Stopping moving downward means that you're actually, accelerating upward to do that, right? So I'm going to draw the weight as a less force, right? Okay. So the first thing we want to do is do a little Suvat here, right? So I'm going to reserve this space here for Suvat. Okay. It's moving downward. That's its initial velocity is negative 5.31. Its final velocity, since it's arrested, right, in police custody, is 0. The acceleration is what we want to find, and the time is 2.10 seconds, right? I think this calls for just using v is u plus at, right? So 0 equals negative 5.31, right, plus a times, what is TOC? What is that guy? 2.10. Okay. Now notice this, when we do this, this guy's going to go on the other side and become positive, and then we're just going to divide by 2.10. So the acceleration ends up being just positive 5.31 divided by 2.10. And that's positive 2. And you got to be very careful with these things, right? 2.5286. Now we have 3 sig figs there. Here I've got 1, 2, 3, 4, 5. If you carry 2 extra sig figs, right, then you are just golden, right? No way that we're going to be off, right? Okay. So now we're set. I think we can set up our thing. I think we need to figure out the weight, though. The weight is going to be 1350. So we've got our acceleration, in other words, right? So weight is going to be 1350, right, times 9.81. So the downward force of 13,243. Okay, and that's newtons, and that's going to be a downward force. That's what this guy is. Here's our, I guess our unknown force is the upward force, right? And now we're set. We can use F equals ma. And the forces are an unknown force, right? Minus the weight, 13,243.5, right? And then that equals 1350 times this acceleration that we figured out, 2.5286. Okay. So let's go that guy times 1350. And that's 34, this side here ends up being 3413.57. And I just basically, I didn't type that number in, I just used the number that I had on my calculator, right? And then we have T minus 13,000. Right, and now we're all set. I guess I'm going to add this guy to that side, right? So plus just adding that to both sides here. Do a little calculated work here. and I get that the tension equals 16,657.07. We have 3 sig figs, so I guess we have to say, we could say 16,700 newtons, right? Right? Or we could say, if we wanted to be all fancy, we could say 16.7 kilonewtons, right? Let's see if I can circle that. I'm getting better and better at the bamboo thing. Okay. The only other one, and I don't have an example of this, is that we could tell you what the tension is, you could figure out the acceleration, and then do the SUVOT afterwards. Okay. Just make sure you're actually using an actual formula for SUVOT. But yeah, I think you should be good.